I'm going to go through 4 examples of different types of partial fraction questions, and then we'll summarise at the end. So we'll start with a fairly straightforward one. So the idea is we're going to split this up so that we have one fraction over this and one over the x plus 4. And we're going to have those added together, and we're just going to stick a and b on the top for the moment because we don't know what they are. And so our task now is to work out what a and b would be. So we're going to do that by reversing this process here as if we were going to add these fractions together. So if we did that, we'd have 2x plus 1 x plus 4 on the bottom, and then we'd have a times the x plus 4 plus b times the 2x plus 1 on top. And so we can see that the bottoms are the same as what we started with, therefore the tops must equate. So we can say that x plus 18 must be the same as a x plus 4 plus b 2x plus 1. There are 2 ways that you can work out what a and b is. We're going to start by using the one where we substitute. So what we're looking at is to get rid of one or other of these brackets. So to get rid of this bracket, x would need to be minus 4. So let's use x equals minus 4. So on the left hand side here, that's going to give us minus 4 plus 18, so that's going to be 14. This bracket here is going to disappear. So we're just left with this one over here. So 2 times minus 4 is minus 8, plus 1 is minus 7. So we've got minus 7b. So that leads us to b being minus 2. Now we do the same idea again, but this time we want to find a value of x to substitute and make this disappear. So for that, we're going to need that to be minus a half this time. So if x equals minus a half, then we're going to have minus a half plus 18. So that's going to be 17 and a half on this side. The b is going to disappear. So we're going to have a times minus a half plus 4, so that's 3 and a half. So we've got 3 and a half a. Now to make life easier, if we double both sides, we'll get 35 equals 7a, and therefore a equals 5. And so now we've been able to split the original fraction into its partial fractions, and it would be 5 over 2x plus 1 plus minus 2 over x minus 4. Of course, normally we wouldn't write that plus in the middle, so let me just take that away. And so we'd have that. In this second example, the bottom doesn't look quite the same. We don't have those 2 brackets multiplied together. But if you look more closely, you'll see that the bottom is an example of difference of squares. So we can write that as 5x plus 9 over x plus 3 x minus 3. So now we're going to split that up as before. So we're going to have a over x plus 3 and b over x minus 3. So that means that the top 5x plus 9 is going to be equal to a times x minus 3 plus b times x plus 3. So this time I'm going to show you the alternate method for working out a and b, and that involves equating the coefficients. So the coefficient of the x term on the left hand side is 5. So that will be equal to a plus b. And then we've got 9 as a number on the left hand side, and that's going to be equal to minus 3a plus 3b. So now you have a pair of simultaneous equations that you can solve. So I'm going to multiply the top one through by 3 to make life easier. So we'll have 15 equals 3a plus 3b. I'll write the other one underneath again just to make it easier to see. So now if we add these two together, we're going to get 24 equals 6b, and therefore b equals 4. And then substituting that into this equation over here, we can see we're going to get 5 equals a plus 4, and so a must equal 1. So our partial fractions will look like 1 over x plus 3 plus 4 over x minus 3. So here's a slightly more complex example. Focusing on the bottom, what you can see is we've got a squared bracket in there. And what happens when you have a squared bracket is that it's going to mean that we're going to end up with actually 3 fractions here. So the first one will be a over x minus 2 squared, but then the second one will be over just x minus 2. So if you have a squared bracket on the bottom, it means it will turn into 2 partial fractions, one with the squared bracket bottom and one with just the single bracket. And then we'll still need a third one here with the 3x plus 2. So from here on in, the rest of it is exactly the same. So we've got x squared plus 13x minus 6 will be equal to a times 3x plus 2. Just imagine what you'd have to do if you were literally adding these together at the top here. And then we'd have plus b, which is going to have x minus 2 and 3x plus 2 multiplying it. And then plus c, which is going to have x minus 2 squared. Okay, so I'm going to start by doing a substitution. I'm going to substitute x equals 2, and that will knock out these brackets here, so that will enable me to find out what a is. So when x is 2, on the left hand side we're going to have 2 squared, which is 4, plus 13 times 2, which is 26, minus 6, so that equals 24, and that's going to be equal to a times 3 times 2 is 6, plus 2 is 8, so that's 8a, and that's going to lead us to a equals 3. Now the next thing that I'm going to do is I'm going to substitute in x equals minus 2/3. This time that will knock this bracket out so that we can find c. So x squared will be 4 over 9 plus minus 26 over 3 minus 6. So I'm going to tidy that up, put it all over 9. So we'll have 4 minus 78 minus 54, which is going to equal minus 128 over 9. Okay, so that's the left hand side. So now what we're going to do is work out the right hand side. So that will be just this C term over here. So it's going to be minus 2/3 minus 2. If you turn that into an improper fraction, that's going to be minus 8 over 3 squared, which is going to give us 64 over 9. And sorry, that's obviously going to be times by C. So we've got minus 128 over 9 equals 64 over 9C, so we can ignore the 9's, and so C will be 128 divided by 64, which is 2. It'll be minus 2. So now I'm going to equate coefficients in order to find B. And in this particular case, I'm going to equate the numbers here. So we've got minus 6 will equal 2a. Now, I'm going to need to think about this. So the only number that we'll get from this middle section here will be minus 4, minus 2 plus 2 multiplied together. So that'll be minus 4b. And then here we'll have minus 2 times minus 2 from this one. So that'll be a plus 4c. And we know what A and C are. So we've got minus 6 equals 2 3's, which is 6, minus 4b, plus 4c, which is minus 2. So that's minus 8. So rearranging all of that, we're going to get 4b equals 12 minus 8. So that's going to be 4. And so B in this case equals 1. Tough looking one here. What we need to do first with this one is we need to divide first, and that's because what we've got here is an improper fraction. So it's improper because on the top we've got an x to the power of 4. If you multiplied out the brackets on the bottom, which we need to do anyway for the division, you'll see that we've only got an x squared term as its maximum. And so because that's higher degree on the top than the bottom, that means that there's a whole part, if you like. So we're going to turn it into a mixed number, if you like. So let's multiply these out. So we're going to get 2x squared minus 5x plus 4x minus 10, and tidy that up. We're going to get 2x squared minus x minus 10. So as I said, we're going to need to do algebraic division first. So we're going to divide by this. So we've got 2x squared minus x minus 10, and we're going to divide the 4x to the power of 4 minus 2x cubed minus 26x squared plus 8x plus 22. So 2x squared into 4x to the power of 4 is 2x squared. And then we multiply through, so that'll give us that. And then we'll have minus 2x cubed and minus 20x squared. Take that off so we can see we'll get nothing from the first two. Minus 26 minus minus 20 means we'll be left with minus 6x squared. 2x squared into this is going to be minus 3. multiply through, we're going to get minus 6x squared plus 3x plus 30, which we need to take away. If it helps, bring those down. So we've got 8x minus 3x, which is 5x, 22 minus 30, which is minus 8. So our original fraction is now a whole part, which is 2x squared minus 3, plus a fraction part, which is 5x minus 8 all over x plus 2, 2x minus 5. So we needed more space, but I've written out the fraction again. Alright, so we're going to turn the fraction part into something over x plus 2 plus something over 2x minus 5. So that means that our 5x minus 8 is going to be equal to a 2x minus 5 plus b x plus 2. I'm going to opt to go for equating coefficients. So 5 will be equal to 2a plus b, and minus 8 will be equal to minus 5a plus 2b. So I'm going to double the top one. So that will give us 10 equals 4a plus 2b, minus 8 equals minus 5a plus 2b. Let's take those away. So 10 minus minus 8 is 18. 4 minus minus 5 is 9a. So a will equal 2. Let's substitute that in. So we've got 5 equals 2 times 2, which is 4, plus b. So b equals 1. So let's just summarise what we've learnt. With partial fractions, the bottom of the fraction needs to be a product of linear functions, single brackets. Split the bottom into separate fractions with tops a, b, c and so on. Then use either substitution to eliminate brackets or equate coefficients, or both, to find the a, b, c, whatever you've got. Watch out for difference of two squares on the bottom. Also watch out, because if you get a squared bracket on the bottom, remember that you're going to need two fractions to replace it. One with the squared version and one with just the single bracket. And if the fraction is improper, that means that you've got higher power or the same power on top as you have below. Then use algebraic division first to get the whole part and the fraction, and then use the same technique on the fraction as before.